Hi everybody and welcome back to my channel. In this video we are going to be talking about dividing polynomials using the synthetic division method. So let's look at our first example. In this example we are given 6x to the power 2 plus 5x minus 13, which is our dividend, being divided by x plus 2, which is our divisor. So the first thing is to always make sure that your dividend is written in general form, in standard form, whereby the highest exponent is written first. So here our highest exponent, which is our degree, is 2, followed by the exponent of x, which is 1, and lastly followed by 0. And also the next step that we have to do is to check if the coefficient of x in our divisor is 1. So in this case our coefficient of x in our divisor is 1 because it's x plus 2. And the third step would be to take the denominator, which is our divisor. So now let's take the divisor and equate it to 0. So we take x plus 2 and let it be equal to 0, and then solve for x. Solving for x here is going to give us x is equal to negative 2. And the next step would be to write the coefficients of our variable in our dividend together with the constant. So we are going to write 6 as our first number, and followed by 5, which is the coefficient of x, and lastly followed by negative 13, which is our constant. And on the left side we have to put the value of x that we got from equating our divisor to 0. So in this case x was negative 2. The next step would be to draw a line here and bring down the first number, which is our leading coefficient of 6. So let's bring the 6 down and write it here. Now the step that follows is to multiply negative 2 by 6. So we are going to multiply and we write the answer here below 5, and we add. And we keep repeating the same steps until we find our remainder. So let's multiply negative 2 multiplied by 6. This will give us negative 12. And then we add the negative 12 to 5. So 5 plus negative 12, that's negative 7. And then we repeat the same process again, where we multiply. Now we multiply negative 2 multiplied by negative 7. Negative 2 times negative 7, that's positive 14. And we add again. So negative 13 plus 14, that's positive 1. So the 1 then becomes our remainder. So the 1 is our remainder, and what we got here are the coefficients of our variable x in the dividend, into the quotient. So what we got here, 6 and negative 7, are going to be the coefficients of our variable x in our quotient. Now let's go and write our answer now. Because our original question had a degree of 2, it was 6x to the power 2 plus 5x negative 13. Our answer is going to start from a degree of 1 less the degree in our dividend. So this one was x to the power 2. Our answer is going to start from x to the power of 1. So it's going to be 6x to the power of 1 negative 7 with a remainder of 1. So the remainder of 1 will be plus 1 divided by our divisor, which was x plus 2. So divided by x plus 2. So this is our final answer for example number 1. 6x minus 7 plus 1 over x plus 2. That's it for example number 1. Now let's move on to example number 2. Moving on to example number 2, we are given 7x to the power 4 plus 9x to the 3 plus 2x plus 4 being divided by x plus 1. So if you look at our exponents of our variable x, the first one is 4, the second one is 3, the third one is 1, and lastly 0, because we don't have an x here. So you can quickly realize that x to the power 2 is missing in our question. So what we need to do is to rewrite our question and add a 0x to the power of 2. So this is going to be 7x to the power 4 plus 9x to the power 3 plus 0x to the power 2 plus 2x plus 4. So this is being divided by x plus 1. All right. Now, the second step would be to check if the coefficient of x in our divisor is 1. In this case, yes, the coefficient of x is 1 because it's x plus 1. So we can go ahead and write our coefficients of x, including our constant. So it's going to be 7, followed by 9, followed by 0, followed by 2, and lastly by 4. And on the left side, we need to take x plus 1 and equate it to 0. So if we take x plus 1 and let it be equal to 0, this will give us x to be minus 1. Now you go and plug in your negative 1 on the left side here, and you bring down your 7, draw a line and put your 7 there. You always bring down the first number down here. Now let's multiply. So we are going to say negative 1 multiplied by 7, it will give us negative 7, and we write it below the next number, which is 9, and we add, and then 9 plus negative 7, that's positive 2. We write our positive 2 there. We repeat the same procedure again. Negative 1 multiplied by 2, it will give you negative 2, and we add 0 plus negative 2, that's a negative 2. We multiply again, negative 1 multiplied by negative 2, that's positive 2. And we add 2 plus 2, that's a 4. We multiply again, negative 1 multiplied by 4, that's negative 4. We add 4 plus negative 4, that's a 0. So the 0 is our remainder. The 0 is our remainder. And then the numbers that we got here are the coefficients of our variable x as our quotient. So, because if you check now, our initial question had a degree of 4, it means our solution, our quotient, is going to have a degree of 3. Always subtract 1 from the degree of the in the question. So now we are going to have 7 multiplied by x to the power 3 plus 2x to the power of 2 negative 2x and then positive 4. So this becomes our quotient. This becomes our answer. Because we have a remainder of 0, we don't need to write the remainder here. So our final answer is 7x to the power 3 plus 2x squared negative 2x plus 4. That's it for question number 2. In our next example, example number 3, we are given 5x to the power 4 plus 12x cubed plus 28x plus 3 divided by x plus 3. So let's check if our exponents of our variable x are written in descending order and always decreasing by 1. So the first one is 4, followed by 3, followed by 1, and lastly by 0. So we are missing an x to the power of 2. So we need to add a 0x to the power of 2. So we have 5x to the power 4 plus 12x to the power 3 plus 0x to the power 2 plus 28x plus 3, and this is being divided by x plus 3. Now let's check if our coefficient of x in our divisor is 1. We have x plus 3 as our divisor, which means our coefficient of x is 1. So what we need to do is to go ahead and list the coefficients of our variable x from our dividend. So we have 5, followed by 12, followed by 0, followed by 28, and lastly by 3. And then we take our divisor, which is x plus 3, and we equate it to 0. So setting x plus 3 is equal to 0 and solving for x gives us x is negative 3. So we put negative 3 on the left side, bring down our first number, which is 5, and beginning with our division. So now we are going to multiply negative 3 multiplied by 5. This gives us negative 15. And we add. So 12 plus negative 15, that's negative 3. And then we keep repeating the same process. Negative 3 multiplied by negative 3, that's a positive 9. So let's write a positive 9 there and add it to 0. 0 plus 9, that's a 9. And now we multiply again. Negative 3, multiply it with 9. This will give us negative 27. And we add 28 plus negative 27, that's a 1. And then we multiply negative 3 multiplied by 1, that's a negative 3. And add 3 plus negative 3, that's a 0. So this 0 is our remainder. And now let's write our answer. If you check in our original question, the degree was 4. So our answer is going to have a degree of 3. So it's going to be 5x to the power 3, negative 3, x to the power of 2, plus 9, x to the power of 1, which is just 9x, and then plus our constant of 1. So this is our answer. Because our remainder is a 0, it means x plus 3 can divide this polynomial. It means x plus 3 is a divisor of 5x to the 4 plus 12x cubed plus 28x plus 3. So that's it for example number 3. Let's move on to the next question. In example number 4, we are given 35x cubed negative 20x squared plus 5x minus 30 being divided by 5x minus 10. So as usual, we have to always check if our exponents of our variable are written in descending order. So we have x to the power 3 followed by x to the power of 2 followed by x here to the power of 1 and lastly by our constant. So this one is okay. And then the next step is to check if our coefficient of x in our divisor is 1. In this case, our coefficient of x in our divisor is 5 because it is 5x minus 10. So what do we need to do? We need to rewrite our polynomial in the same order and divide each and every term by the coefficient of x in our divisor. Since the coefficient of x is 5, we're going to divide each and every term by 5. So we divide both our dividend and our divisor by the coefficient of x in our divisor. So let's rewrite the simplified question. 35 divided by 5, that's a 7. So this will be 7x to the power 3. Negative 20 divided by 5, that's negative 4x to the power 2. 5 divided by 5, that's a 1. So this is plus x. And negative 30 divided by 5, that's negative 6. So this is being divided by. Now let's simplify our divisor. Now our divisor changes to x. 5 divided by 5, that's a 1. So we have x here. Then negative 10 divided by 5, that's negative 2. So our new and simplified question now is 7x cubed minus 4x squared plus x minus 6 being divided by x minus 2. Now the coefficient of x in our divisor is 1. So now we can start with the division process. So let's list the coefficients of our variable x starting from 7. So we have 7 followed by negative 4 followed by 1 and lastly negative 6. And let's take our divisor, which is x minus 2, and set it to 0. Solving this gives us x is equal to 2. So this is the number that we put on the left side here. And then we bring down our 7, draw our line. So let's plug in our 7 there. Now let's multiply. 2 multiplied by 7, that's 14. So let's write our 14 and we put a plus sign. So 14 is being added to negative 4. So minus 4 plus 14, that will give you a 10. Now let's multiply again. Let's repeat the same process. 2 multiply 10, that's a 20. So let's put 20 there and add. 20 plus 1, that's a 21. Let's multiply again. 2 multiply 21, that's 42. Let's add. Now 42 minus 6, that will give you a 36. So 36 is our remainder. Now let's go ahead and write our final answer. Since our original question, our original polynomial had a degree of 3, this is the degree of 3, and this implies that our answer, our dividend, our quotient, will have a degree of 2. So we are going to say 7x to the power 2 plus 10x plus 21 with a remainder of 36. So plus 36 being divided by our divisor. But now our divisor, we take x minus 2. We take the simplified divisor, not the original one. So being divided by x minus 2. So this is our final and simplified answer to example number 4. Let's move on to the next question. In example number 5, we are given 4x to the power 4 minus 5x squared minus 13x plus 3 being divided by 2x minus 3. So if we check our exponents of our variable in our dividend, you will see that the first one is 4, which is our degree, followed by 3, followed by 2, followed by 1, and lastly by 0. So this means that x to the power 3 is missing in our question. So we are going to go and rewrite our polynomial as 4x to the power 4 plus 0x to the power 3 negative 5x to the power 2 minus 13x and lastly plus 3. And also if you check our dividend, our divisor, if you check our divisor, which is 2x minus 3, you will see that the coefficient of x in our divisor is not 1. The coefficient of x is 2. So what we need to do is to divide each and every term by this coefficient of x from our divisor, which is 2. So we're going to do this. This was 2x minus 3. Now we have to divide each and every term by 2. So divide by 2, divide by 2, divide by 2, divide by 2, and also here we divide by 2. Now let's write the simplified question. So the first one will change into 4 divided by 2, that's 2, so it will change into 2x to the power 4, followed by the second one will remain 0, 0x to the power 3, followed by negative 5 over 2 x to the power 2, followed by negative 13 over 2 x, and lastly 3 over 2. And our denominator, our divisor, will change into 2 divided 2, that's 1, so it will change into x minus 3 over 2. Now we need to take the divisor and equate it to 0 and solve for x. So if you take x minus 3 over 2 and set it equal to 0 and solve this, it will give you x is equal to 3 by 2. Now we are going to write our coefficients of our variable x starting from 2. So we're going to say 2 followed by 0, followed by negative 5 over 2, followed by negative 13 over 2, and lastly followed by 3 over 2. Now on the left side we are going to put the 3 over 2, which is the value of x that we got after equating the divisor to 0. We'll draw our line and we'll bring down the first number, which is 2. Now let's multiply. We're going to multiply 3 by 2 multiplied by 2. If you multiply 3 over 2 multiplied by 2, you get a 3. And now we add 0 plus 3, it will give you a 3. Now let's multiply 3 over 2 multiplied by 3, you get 9 over 2. Now let's add 9 over 2 plus minus 5 over 2. So we have 9 over 2 minus 5 over 2. It will give you a positive 2. So let's put our 2 there. Now let's multiply again. 3 over 2 multiplied by 2, it will give you a positive 3. Let's put our addition sign and add. Now negative 13 over 2 plus 3. So negative 13 over 2 plus 3. This will give you negative 7 over 2. So this is negative 7 over 2. Now let's multiply 3 by 2 multiplied by negative 7 over 2. We are going to get negative 21 over 4. And we add. So 3 over 2 plus negative 21 over 4. So 3 over 2 negative 21 over 4 will give you negative 15 over 4 as our remainder. So negative 15 over 4 is our remainder. Now let's write our final solution. So since our original question had a degree of 4, it was 2x to the power 4, it means that our answer is going to have a degree of 3. So let's write, the first one will be 2x to the power 3, followed by 3x to the power 2, followed by plus 2x with our constant of negative 7 over 2, and lastly this is our remainder. So our remainder is negative 15 over 4. So we know that our remainder of negative 15 over 4 is being divided by our divisor, the simplified divisor, which is x minus 3 over 2. So we're going to divide this by x minus 3 over 2. Now let's simplify our divisor. Let's simplify this part here. So let's leave the minus aside for now. Let's take 15 over 4 and divide it by x minus 3 over 2. So we're dividing this by x minus 3 over 2. Now let's simplify the bracket first. Let's simplify this bracket. So we're going to have 15 over 4 being divided by, this is x over 1. So to simplify this, it's going to be 2x minus 3 divided by 2. Now since we are dividing fractions, this implies that we have to change the division sign into a multiplication sign and flip the second fraction. So this is the same as saying 15 by 4 multiplied by 2 over 2x minus 3. And let's simplify it. So the 2 will cancel into 4 to give us 2. Now the simplified remainder will be 15 divided by 2 and open bracket 2x minus 3. So this is our simplified remainder. Now let's write the final answer now. So let's write our 2x to the power 3, 2x to the power 3 plus 3x to the power 2 plus 2x minus 7 over 2 with our remainder of, but let's not forget that there was a negative sign here. So let's keep our negative sign here. So it will be negative 15 divided by 2, open bracket, 2x minus 3. So this is our final and simplified answer. 2x to the power 3 plus 3x squared plus 2x minus 7 over 2 with a remainder of negative 15 over 2 multiplied by 2x minus 3. That's it for example number 5. Let's move on to the next question. Let's move on to example number 6. In this example, we're given 9x to the power 4 plus 8x squared plus 2x plus 5 divided by 3x plus 1. If you check our exponents, in our dividend, you see that the first one is 4, followed by 2, followed by 1, and lastly by 0. So we need to rewrite our dividend with an additional 0x to the power of 3. So now we have 9x to the power of 4 plus 0x cubed plus 8x squared plus 2x plus 5. Now our exponents of our variable are now in descending order and decreasing by 1, from 4 to 3 to 2 to 1 and lastly to 0. And the next step, our next step would be to check if the coefficient of x in our divisor is 1. And in this case, the coefficient of x in our divisor is not 1, it is 3. So we need to divide all the terms by 3. So we're going to divide this by 3, divide 0 by 3, we divide 8 by 3, we divide 2 by 3, and we divide 5 by 3. And we do the same to our divisor, which was 3x plus 1. We divide every term by 3. Now, let's write the simplified question. So 9 divided 3, this will give you a 3x to the power 4 plus 0 divided by 3, that remains is 0. So we have 0x to the power 3, and this is 8 over 3, x to the power 2, followed by 2 over 3, x, and lastly 5 over 3. And our divisor is now 3 divided 3, that's a 1. So we're going to remain with x here, plus 1 over 3. Now we take the denominator, which is our divisor, x plus 1 over 3, and set it equal to 0. So we are going to say x plus 1 over 3 and set it to 0. And then solve for x. Solving for x here will give us x is negative 1 over 3. Which leads us to the next step. Now let's write our coefficients of our variable x from the dividend. So we have 3, 0, 8 over 3, 2 over 3, and lastly 5 over 3. So let's write here 3 followed by 0, 8 over 3, 2 over 3, and lastly 5 over 3. And we put the value of x that we got from solving this equation here, x plus 1 over 3 is equal to 0. So this gave us x to be negative 1 over 3. So let's put negative 1 over 3 there. Now let's start with our synthetic division. So we're going to bring down our 3 and write it down here. Now let's multiply. Negative 1 over 3 multiplied by 3, it will give us negative 1. And we add the negative 1 to 0. 0 plus negative 1, that's a negative 1. Now we multiply again. Negative 1 over 3 multiplied by negative 1. This will give us a positive 1 over 3. And we add 8 over 3 plus 1 over 3. It will give us 9 over 3, which is just 3. And then we multiply negative 1 over 3 multiplied by 3. It will give us a negative 1. Now let's add 2 over 3 plus negative 1. So we have 2 over 3 minus 1. It will give us negative 1 over 3. So we have negative 1 over 3. Now let's multiply negative 1 over 3 multiplied by negative 1 over 3, it will give us a positive 1 over 9. And then we add. So we have 5 over 3 being added to 1 by 9. This will give us 16 by 9. So we're going to use 16 by 9 as our remainder. Now, let's write our final answer and then simplify the remainder part. So now we are going to write our answer. Since our original question had a degree of 4, it implies that our answer is to have a degree of 3. So we're going to have 3x to the power of 3 minus 1x, which is just minus x to the power of 2 plus 3x and our constant of negative 1 over 3 with our remainder of 16 over 9. So our remainder is 16 over 9, which is being divided by our simplified divisor. Our simplified divisor was x plus 1 over 3. So let's divide this by x plus 1 over 3. Now let's simplify our remainder here. So let's put it aside here. Let's put 16 over 9 being divided by x plus 1 over 3. So x plus 1 over 3, which of course becomes 16 over 9. And let's simplify the inside bracket, which is x plus 1 over 3. So this is x over 1. So if you simplify the inside bracket, you're going to have 3x plus 1 over 3. And since we're dividing fractions, we are going to change the division sign into a multiplication sign and flip the second fraction. So now it becomes 16 multiplied by 3 over 3x plus 1, which can simplify to, so let's divide here. When we divide 3 into 9, that's a 3. So our simplified remainder will be 16 divided by this 3, open bracket, multiplied by 3x plus 1, close bracket, which implies that our final answer now, our final and simplified answer will be 3x to the power 3. So we have 3x to the power 3 minus x squared plus 3x minus 1 over 3 with our remainder of 16 over 3 into 3x plus 1. So plus our remainder of 16 divided by 3, open bracket, 3x plus 1, close bracket. So this is our final answer to example number 6. That's it for this question. Let's move on to the next question.